Hey pals, John here from Math with Mr. Barnes, bringing you another wicked awesome math video as always. I know I'm a stranger. I haven't really been giving this channel much attention lately. There's been a lot of changes going on. 2 kids, big move, new job, so it's been taxing on me, so I haven't had much free time. But I am reinvigorated. I'm going to try and put as much effort into this video series as possible, and this is the first video in my calculus video series. I know I've made some calculus videos in the past, but it's personally my favorite subject, my favorite topic in math, and this is the first video on limits, and specifically using limits or factoring within limits. So it's one of those things where, you know, it's kind of the first topic a lot of calculus classes hit within the first few weeks. And my students are getting ready to write a big exam, so I'm helping them out with some review stuff, and hopefully you guys can get some use out of this. So without further ado, here's the video. If you like this video at all, please share, like, and subscribe. Hey pals, Mr. B here again, bringing you another long-awaited math video. I've been on hiatus kind of from my YouTube channel over the last little while. But I've had some requests from students to make some videos, so I thought I might start with my calculus class. They're getting ready for a calculus placement test in June. So I thought I might start taking them through some of the main topics that will be on that assessment. And, you know, these are the main topics that are in any calculus course, so they're beneficial to a lot of people taking calculus, so if you can get some joy out of this video, I'd appreciate a like and subscribe, and let's get it going. So this video is all about limits by factoring, and of course, factoring is one of the things that you would learn in a pre-calculus course, but it's also one of the things, knowing I've taught pre-calculus for many years, grade 10 math, grade 11 math, and even just like an advanced grade 12 math. Factoring is one of the things that students struggle with a lot because there are a lot of different techniques, and sometimes you're curious about what technique might work here and that kind of thing. So with limits by factoring, your factoring ability is what's going to determine whether you can do this or not. So I'll take you through 3 different examples, and then I'm going to do another video that takes you through a couple of other examples, and I'll explain what they are as we go through. All right, so this first one, we have a example here. So it's just a rational function, and what you should notice about the top, I hope you notice anyway, is that guy is difference of squares. So difference of squares. So what does that mean? Well, it's kind of in disguise a little bit, actually. I can pick it up. Maybe you can't right now. So let's actually make the first move, and I'm just going to change this, make it a little tiny bit bigger. Maybe you can't see that first move right now, but let's give it a shot. So I got the limit as x goes to -1, like I tell my students. Writing the limit down is not optional. You have to do it every time. So we take the 5 out, just like that. And now maybe it's a little more clear how you can see the difference of squares. So if you look at it, the difference of squares that I have here is x squared minus 1. So the reason why we call it difference is because there's a subtraction sign, and it's x squared, which is a perfect square, and 1, which is a perfect square. So you got to remember that list of perfect squares like 1, 4, 9, 16. You can generate it any time by just going, 1 times 1, 2 times 2, 3 times 3, etc., etc. So how do you factor that? Well, the difference of square form is actually pretty straightforward. So I'll write it the next step. So I'll write my limit again. So the limit as x goes to -1. Keep that 5 on the outside. Can't forget about that. So difference of squares always ends up with a plus and a minus separating them. Okay? Because really, if we were going to take the square root of 1, a lot of times what people forget is that the square root of 1 is actually plus and minus. You have 2 solutions. You have 1 and -1. So when we write our actual bracket, we need to make sure we include both of those solutions. So the solutions are x plus 1 and x minus 1. So that takes both solutions into account of our difference of squares. And then on the bottom, we rewrite the x plus 1. Now, one of the things I've been emphasizing to my students over the last few years is before you even start a limit, you should know what is going to cancel. So if you look at this limit, it's x goes to -1. What that means is I want to cancel x plus 1, the associated linear factor with that limit. So in this case, that's what cancels. So if you look here, that x plus 1 and that x plus 1 is what cancels. So now what I can do is I can go back and I can rewrite my simplified limit. So I'll rewrite it as limit as x goes to -1. And then my expression here that I have, I'll just rewrite it. Actually, there's no line on the bottom now, so it's just 5x minus 1. So now that I have that written, so I've canceled away. And maybe I should have mentioned this from the beginning. I'm getting a little ahead of myself for this video. I'm rusty. I haven't done a video in a long time. I've canceled out what's known as the indeterminate form. So really, I should have mentioned this at the beginning. So let's try this. So if you look at this, if I sub -1 into this thing, so if I put -1 in here, what ends up happening, of course, is you get this thing, which is 0 on the top. So you get 5 subtract 5, which is 0, and then 0 on the bottom. So you get 0 over 0, which means is this is called indeterminate, I'll leave it at that, form. So indeterminate, of course, if you know what indeterminate means, it means I can't figure it out, right? So you need to do something else. So that something else is factoring. So all right, so back to the job at hand. Once you've eliminated that indeterminate form, the factors that cancel, then we are good to sub. So once we sub with the x equals -1, we no longer are required to write that limit. So I end up with this, which is -2 here in the bracket. So I sub the -1 in for x, and I got -2 back. And I end up with -10. And there it is. That's my limits by factoring. So that's the first example, and that is a difference of squares example. So let's step it up a little bit and try a slightly harder one. So our second example here, we have another quadratic, although this one is a more complicated quadratic. It's not a difference of squares or something that we can easily look at and factor. We have to use like a slightly different method. Now we're still expecting that this one goes to -1, so we're still expecting that x plus 1 on the bottom to cancel. So that's a good start. And we can kind of make the assumption that this is indeterminate form. The reason being is because I made the question. But you know, if you were on a calculus test or just studying or whatever, doing some practice questions, this would always be your first try to do, right? So you'd always just see if you can use direct substitution, sub it in, and see what you can get. But I can immediately tell that this one, you get 0 over 0. So basically, that it doesn't mean it does mean something. It means we have to do something more, but nothing that we didn't really already know, okay? And like most calculus tests, you're probably going to have to do something. So let's go ahead and try and factor this top guy over here. So I'll take it over to the side. I don't like to do a lot of workings within my limits because they get a little bit complicated sometimes, and I want to sort of limit the amount of workings I have in it. See what I did there? So because this is a complex trinomial, what I need to do in order to factor it, I need to multiply that 2 times 1. So it adds to give me 3, so that middle number right here, and then multiplies to give me 2 times 1, which is 2. All right, so I need to think about the numbers that make that work. So what adds to give me 3 and then multiplies to give me 2. I usually just think about what multiplies to give me 2, and then, well, 2 is pretty simple. It's just 2 times 1, and 2 plus 1 is 3. So it's 2 plus, or 1 plus 2 equals 3, and then 1 times 2 equals 2. So those numbers satisfy the condition that I set forward. Multiplies give me 2, adds give me 3. Well, 1 and 2. So then what I do is I go x plus 1 and x plus 2. So that's my factored form, but we're not quite done yet. What makes this one a little bit tricky is the fact that I've got that little pesky guy hanging out right there in front. That 2 messes everything up. So I had to account for that by dividing by both of these by 2. So I divide that by 2, and I divide that by 2. So if something simplifies, which in this case it does really well, this one does simplifies 2 divided by 2 is just 1. If something simplifies, we simplify it. If something does not simplify, then what we need to do, if there's a denominator, then we take it up and put it right in front of that x. So it becomes 2x plus 1. All right? So this might be a method you learned in your class. It might not be a method. This is what I call the Barnes method in my classes. So the BM, the Barnes method. Whether you use it or not, it's kind of up to you. There is another way, decomposition. I'll drop a video in the description if you want to watch a video on decomposition. If that's how you do it, you need a refresher. But personally, decomposition is a great skill. You need to know it. But for complex trinomials, personally, I don't think you beat the Barnes method. All right, so now we go ahead and we rewrite our limit, and we're going to replace that complex trinomial with this guy. So 2x plus 1, and then x plus 1, and then I'll rewrite x plus 1 right there. So again, we know what's going to cancel. It's the x plus 1, so we're well prepared to do it. That cancels, that cancels. And let me get my purple back. And then we can rewrite our simplified limit, just like this. And I got my 2x plus 1. And now I can go ahead and sub the negative 1 in. So I'll go ahead and do that. So 2 times negative 1 plus 1. And that's negative 2 plus 1, which is negative 1. And there it is. That's my limit. So sometimes you get these show up, guys, but it's a really, once you get the hang of this factoring technique, I'm telling you, you're going to love the Barnes method. So don't sleep on it. It's awesome. All right, I got one example left, and we'll step it up to a cubic. So there's a couple different types of cubics that you might kind of end up with. So this is a cubic that has 4 terms. There's also a lot of times you'll have a cubic like this, x cubed minus 8. And that is called difference of cubes. So sometimes you end up with that. You need a special technique for that. Difference and plus of cubes. I think that's different and sum of cubes, not plus of cubes. So I'll do that in another video because it kind of deserves like its own little treatment. And so if you end up with one that looks like that, I'll drop the video in the description once I get it done. And I might already have one. I have no idea. So we'll see what happens. All right, so the same idea. Let's pretend for a moment we know this is indeterminate form, so it's 0 over 0. We know what we want to cancel. We got it as it goes to 3. That means we want x minus 3 to cancel. So we need to figure out how to factor this cubic. Well, this cubic is actually a special kind of cubic, which is difference of cubes. All right, so difference of cubes is a, well, it's kind of like, or sorry, not difference of cubes. Did I say difference of cubes? I don't know. I mean grouping, okay? So that's what I meant to say. Grouping is a lot like decomposition. So when you have 4 terms like this is the first thing you want to do with a cubic is you want to group it. So what I mean by group it is I literally group the first 2 terms like this. And I always rewrite this step. Don't get lazy. And I put a plus in between the brackets, and then I write my next 2 terms. The reason why I tell you not to be lazy is because my students are often lazy and they do this. They go like that, and then they go like this, and now all of a sudden they have the incorrect setup for groupings, and you're not going to get it right. So take that extra step and rewrite the 4 terms grouped up to each, and put a plus in between, okay? Plus, 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 plus in between. So now what we can do is we need to factor both brackets with the greatest common factor. So let's look at this first bracket. So I got a cube and I got a squared. So when you're factoring variables, you can always take out the lowest power. So I take out an x squared. And then I end up with, outside the bracket, and I end up with x plus 1. I always tell my students to do just a quick little mental check, distribute back to see if you get the same thing. So we get that. Now with this one, I can take out a negative 9 out of both. So I end up with negative 9 outside, and then I left with x plus 1. Okay? So you know you grouped it correctly if both of these brackets have the exact same thing in them. If they do not, you messed up. All right? So always go back, do a quick check, make sure that satisfies. So with grouping, the reason why this thing works is because the reason why it works is because the brackets are the same. So when we get to this step, we're factoring again, and we take out what's common to each term. So what's actually common is that x plus 1. So what actually we do, we take out that x plus 1 outside. So I literally taking that x plus 1, I'm factoring out of both. And then what I get left with is x squared in front of that bracket and the minus 9. So some of my students don't like to think about it like that, which is perfectly fine. If you got your own way of doing it, I encourage it. They like to think of it as I get left with what's in front, x squared minus 9, and then I just pick one of the brackets. Okay, so like that kind of works too. So the next step is we got to see if there's anything left here to factor. So there is. And again, we got another difference of squares, x squared minus 9. They're subtracted. They're both perfect squares. The square root of 9 is 3 and negative 3. So it's x minus 3 and then x plus 3. So again, like that's pre-calculus. Now I come over here and I'm doing my limit. Okay, so the limit actually is the calculus part you probably learned in your course. So it's all depends on your factoring ability as to how challenging or how easy you can make this to be. So again, we knew x minus 3 was going to cancel before we even start this limit, and we cancel them just like that. And now we're ready to rock with the rewrite. So the limit as x goes to 3. So we end up with x plus 1, x plus 3. So once we know that we've canceled the indeterminate form, which was the x minus 3, we're good to sub. So I have 3 plus 1. And then I have 3 plus 3. So that is, in the brackets here, 4 times 6, which is 24. So guys, that's a great couple of examples, or 3 examples, I guess, in factoring limits by factoring. If you found this video helpful, please subscribe. I'm trying to grow my channel. I'm trying to reinvigorate my math channel for my students and share my love of math. And I'm trying to increase the quality content, so that's going to take time, but little bit by little bit, I will do that. If there's any questions, drop them in the comments. I'm going to try and be a little more active on the comment section. And hope you guys have the best of luck studying, and I'll see you guys in class. Thanks. Thanks for watching, everyone. And if you could do me a big favor, I am a math YouTuber. As of course you're watching a math video, you would know that. But I have a goal of reaching 100,000 followers. So if you could just click that little subscribe button right down in the corner. I feel like I'm kind of begging for subscriptions, but you know what? That's what you got to do. Thanks for watching, and I will see you guys in class. Peace.